Okay, so the topic for today is load balancers. So why do we need load balancers? Let's demonstrate. Let me demonstrate an example. Imaginary situation. So we have two public subnets and an instance, right? So what will happen when, for some reason, the entire availability zone goes down like this? If we have only one instance. Yes, please.
We would lose wherever we are running. Like if we're running a website, we would lose access to it, or whatever application was running on that instance.
Yes, this is totally correct. So how we can avoid these situations? How we can achieve availability in case single availability zone goes away?
So we will use load balancer and then divide the load between the two instances in different availability zones.
Yes, exactly. I gave you a kind of spoiler to say we will talk about load balancers today. That's totally right. First, we will deploy a second instance in a second availability zone. And after that, the next question that we'll have is how would we explain or direct our users which IP address they should be directed to. Let's also highlight this. So there will be like some users. Presumably, each instance will have an IP address. And the question is how exactly a user will understand which IP he should connect to, right? So what is done in this case, exactly as Mohammed described, we need to create a load balancer. So what the load balancer will do is it will work as a central entry point for our users. And distribute traffic evenly across our multiple instances across multiple deployments of our availability zone. Okay, very good. And this is what we will do today. Today, we will create a second public server that will run our game or something else. And also, what we'll do is create a load balancer that will distribute traffic across these availability zones. Usual preparations: git pull, create a branch. And I will switch to code editor and start implementing. Okay, so we can immediately apply our level 1 because we need a VPC. And while it is applying, I will take time, and in level 2, I will first increase the number of our public instances to 2. So we'll go to security group will be the same. Public subnet ID, public subnet ID. 1 second. So here's what we need to change. Instead of public at 0, we need to expose all public IDs and be done like this by using asterisk. And let's be consistent and deploy everything with private. And in this case, we can have it Terraform remote state level up public subnet IDs at bound.index. This means first instance will go to first one, second instance will go to the second one. Okay, very good. And similar thing we need to do with our private subnet IDs, but this one will be at 0. Does it make sense what I just did?
Yes.
Okay.
Yes.
Yeah, very good. Yeah, let's wait a couple more minutes until it is applying. After that, we will apply again because I made this change in output after I ran the apply first time. And then, yeah, Terraform apply again. Pay attention here. Currently, it's only one string, subnet this one and subnet second one. And now what it is doing is instead of single subnet, it gives us a dictionary. So entire dictionary that contains all subnet IDs is being exposed, and we can use it further, and we can query it using our count arguments in this level, kind of. Okay, very cool. Let's run then Terraform apply in level 2. Okay, very good. And what I also forgotten is when we were migrating to our multiple layers to level 2, I forgotten to add some useful outputs. If I'm not mistaken, let's check how the proper spelling. It should be, yeah, AWS instance public. Public IP, okay. Public IP. Let's save it again. And a couple more changes. Let me first enable my VPN so I have proper public IP that is recorded in Terraform. Hold on a second. Is 155. I need to change my IP. Just a little moment. My current one is 185.156.46.116. Okay. And let me test that SSH is working. Yes. And web page is working as well. But let's check it in the browser either. Cool. 248. And the second one, what was it? 383.217.203. And the reasonable question is, how do we distribute traffic across these two versions of our application, right? Because a web browser, a client, can only connect to a single IP at a time. So, and what we are doing is like creating this universal umbrella of elastic load balancer. And this is what we're going to do. But before I do so, I'll change one more thing. No, it will be too long. Now, just in order for us to understand which page belongs to which instance, I have replaced index.html on one of them to just a simple hello message. And the second one will continue to have this 248 game. By the way, do you guys know what's the difference between a single quote and between a double quote and a single quote? Why it gave me this exclamation mark event not found error? Yes.
For the simple quotes, it is considered as a string. For double quotes, the exclamation mark was considered as an event thing, so the
As a system character, yes.
interpreter saw it and
yes, exactly, very good. And this is you should always be aware of. For example, if we declare a variable, for example, color equals red, if we do echo my favorite color is color in double quotes, it will replace this $ color with this variable that we have declared, right? But if we replace it with single quotes, it will treat this $ as just as a letter in our text, and it will say my favorite color is $color. So that's always a good thing to remember about. Okay, we no longer need these instances. So now what I will do is I'll get back to the code editor and create some additional resources for our load balancer. So first, we will need a security group. Nothing extraordinary here. It's just a regular security group. We'll call it load balancer. Don't forget to interpolate the env code into your load balancer name. Description will be that it allows 80 TCP inbound to load balancer, and VPC ID will be our VPC extracted from our remote state data source. The ingress rule should allow 80, and we can leave entire internet over there. There is nothing critical if someone else will be able to connect and play our wonderful game while we are experimenting with it. And standard thing like for egress, everything to everywhere. And also don't forget to give it proper tag so it stays organized. Now what we can do is create the load balancer itself. There are different types of load balancers, external and internal. External load balancer serves traffic to open internet. Internal load balancer serves traffic only within your VPC. So if you have some internal applications that should not be exposed outside, like, I don't know, CRM or Jira or like internal accounting application, internal load balancer is the way to go. Load balancer type is application. It works on layer 7. Also, there is network load balancer that is working on layer 4. That's different layers of OCI, different features and different like bells and whistles correspond to different types of load balancers. We will include it to the security group that we just created. And we'll put it in our public subnets. Yeah, there is a raised hand. Sure, Fadia, go ahead with your question.
Yes, I have a question regarding the egress block from the to port. Why is it exactly 65,000 and why have you specified?
It means 0 to 65,000 means all ports. So usually and by default, egress rules in security group allow all traffic. That simply means that whoever is behind can initiate any connection outside from within the VPC, from within the security group to outside the internet.
Okay, but we're not supposed to do from port 0 to port 0.
No,
it's not the same thing.
That's not the same thing. From point 0 to point 0 will be only port 0. Like this here. That's only port 80. Or if we, for example, do like this, it will be port 80, 81, 82.
Okay, I got
0 to 65, 55 means all and every port.
Within that interval. Yeah.
That's all interval. There are 65,535 ports exists.
Thank you.
Okay, the load balancer itself is created. Now we need to go ahead and create a thing called target group. Target group is kind of an instance behind a load balancer, and essentially like can be described as it describes health check. It gives you an opportunity to define healthy and unhealthy threshold. It gives you opportunity to deploy to point the load balancer to exact page that it should check. And let me demonstrate this. Sorry, just a second. So essentially, we're explaining which port and protocol should be used by the load balancer for it to run the health check. So health check means it connects to an instance, make sure it is responding, and only in this case sending traffic so it can handle the request. And some additional details about how to define this health check. So there is a path, means it will go to index page, or we can redirect it to some certain page. It can do health check on any port that we would like. For example, we might serve on port 8080 instead of 80 and kind of have port redirection. But in our case, this will be the same. It will be either 80 or just simply traffic port. It will means that in order to consider instance healthy and start serving traffic, it should make 5 successful health checks. And there is also unhealthy threshold, means if 2 health checks fails, the instance will be removed from the load balancer. And it will time out after 5 seconds. So if within 5 seconds the load balancer does not receive a response, it will drop and consider the health check failed. Between each attempt, there will be 30-second pause. And in order to consider the request successful, it should return 200 response code, means connection success. And also a couple more resources that we need to create. There is also a thing called AWS Load Balancer Target Group Attachment. It simply means that we are attaching the target group to the load balancer that we created. Basically, we are connecting them with each other, similar to how we connect route and route table and a subnet using route table association. And one more thing called listener. Listener is basically the rule that explains under which conditions to which target group and which health checks should be done. So basically what we're saying here is every time connection comes to port 80 on the load balancer, it forwards the request to our target group which in turn is connected to our targets. And also one more thing, AWS instance. Hold on a second. We have two instances. This means we need to have count equals 2. No, hold on a second. Let me check it real quick. Okay, yeah. So target group attachment attaches the instance to the target group. Means this target group can send this traffic to the instance, and listener rule in turn forwards the traffic from load balancer to the target group. Which means since we have two instances, we can create count equals 2, or actually like this, length AWS instance public. Like this. And I think, and two instances will share the same target group, will be attached to the same target group, and traffic using a load balancer listener with this listener rule will be forwarded to the target group. Let's run Terraform apply, and it will be much easier when I demonstrate it in AWS portal. And of course, obviously, we have some errors that we need to fix. Yeah, stupid mistypes. Where is our load balancer line 29 application? And target group attachment main. Did you mean AWS LB target group attachment? What I really like about Terraform is that when you make a mistype, most likely it will suggest you the proper spelling. That I extremely appreciate, line 56. So when you have some weird and unknown error, first thing you need to do is carefully read it. Might seem that I did not read it, but I did it really fast because I already know where to look. But every time you have something not clear, first just take a moment without a hurry to read the exact error, and it will give you awful lot of details that will give you awful lot of hints about what should be done. Okay, data teref public subnet ID, subnets. Yes, Rodman.
It should be a list, no? Because it says
Yes.
subnets. So
Yes,
maybe
it should be a list, but the thing is, we already have a list. And if we check the Terraform outputs of our level 1,
Mm.
uh, it's already a list. It's a little more. It's a little more tricky. Hold on a second. It will be like very interesting thing for subnet in. For some reason, it does not accept the list that we have and simply wants to reiterate and like rebuild it from scratch. Hmm. No idea what I have changed. I will rewatch recording after it's available for myself and investigate it further. Looks identical to what we had initially. Sorry for that. Yeah, sometimes this happen. Sometimes even I don't have clear answers to questions to what is happening. I hope you will accept that.
I will admit. I have a question.
Yeah.
So, do we need to assign a public IP to the instance as like the user is accessing through the load balancer?
This is great question, and I will demonstrate the answer to these just as soon as we have load balancer created.
Okay.
have a question as well. Now that we have like the load balancer sets and everything like that, how are we gonna access the application? Which IP address are we gonna use?
This question is very similar to the previous one. Let's wait a couple moments and I will show you. I will demonstrate. Okay, now we have this URL, and if we open it in our browser, we should expect a web page. Sometimes it takes a couple moments to have it loaded. Let me reopen it in incognito mode. Okay, it says something to us. Says gateway timeout, means instances are for some reason not responding to it. Let me quickly log into our AWS and investigate this. So how it looks from within AWS portal, it's a good opportunity to look at this. So here is a load balancer. It has the listeners, means forwarding it to the target group. And the target group in turn will have a list of instances assigned under the targets section, and it is saying unhealthy, request timeout. And I think I understand what's the issue. Sorry, I was trying to do this too fast and made additional mistake. Load balancer security group. Actually no. Public security group should allow connections to our load balancer security group. We should add one more ingress rule and say HTTP from load balancer. And here should be security group ID, which means everything that's within the security group is subject to this allowing rule. And the destination will be AWS security group public.id. Let me double check. Forgot to save. Sorry. Okay, never mind. Let's go and open the documentation. Okay, it's called security groups. We will run Terraform apply and get back to AWS, making sure instance become healthy. We will need to wait until health checks and until 5 health checks repeat again. This means like 5 minutes. 5 not 5 minutes. 5 per 30, 2.5 minutes. Let's decrease our timeouts as well, so it's done faster. It can be 2. Timeout and interval can be 2 and 5. Timeout 2 and interval 5, and run Terraform apply one more time. Now you see that this switched to healthy, but again, keep in mind, not because I changed the values of timeout. This was only to speed up the process. This changed to healthy because I have allowed load balancer to talk with the security group of the instance. And now, when we refresh it, hopefully, and yes, it will give us an instance. And answering your guys' question, yes, end users should connect to this load balancer URL. And load balancer will automatically handle and evenly distribute requests to your multiple nodes. That's why on each refresh that you currently see, we are being redirected to the different web page. First instance serves simple hello. Second instance serves the web page. But what we can do with these public IPs? How do we even need them? What's your thoughts?
We don't need them. We can create like if we want to access the instance SSH, we create one public instance and then access it through private network.
Yes, but where do we run our web servers then?
How?
It was almost right, and let me demonstrate it further. In fact, what we can do is instead of using public instances to run our application, right? We can do the same identically and absolutely the same, but on our private instance. We'll keep only one public. It will be at 0. This will go over here. And in our load balancer, we will change everything from public to private. Actually, no. Load balancer should still stay in the public subnet, but the instance that we will use will be private. And also, what we will do is, instead of deploying our web application using user data to the public instance, we will simply cut it from here and put it into our private ones. So what we'll do? Load balancer will sit in public subnet and forward our requests to the web application that is running in the private subnet, and will act as a kind of reverse proxy. And also don't forget to adjust the security group. It should allow load balancer traffic. This means we don't need public IPs at all. Our public IP will be like a load balancer. Let's run Terraform apply one more time and see what will happen. And of course, there are errors that I need to fix. Yeah, it is called private instance. Poor naming, actually. I need to rename it later. And also one more artifact, subnet ID in our public instance should be 0. We no longer have count. We hit yes. Now, what I'm curious, I have never checked it, whether modified user data will actually run or we will have to recreate it. But yeah, let's check and see. So let's keep in mind, even though we changed our infrastructure, the load balancer remained identical. It remained, where is our load balancer? The same. And when we refresh it, it still works. But when we go and check our backend and refresh it here, we have private instances in a private target group. And even, let me see a very interesting thing. By adding load balancer, you are adding additional level of redundancy. This instance failed, most likely because user data did not apply properly. However, this one was the second one that created when we added count, and user data ran correctly from scratch, from zero, and it is currently healthy, right? So we can, like, for example, swap and pull our instance out of the load balancer if it's not working well. We can pull it back if needed. And basically, this is how we making our application even more highly available. And basically, the final step of our today's session is that let me add everything, commit, and create a pull request. And while we have still have several minutes, let me guys know if you have any questions. If not, then thank you guys for today and talk to you next week.
Thank you for today.
Yeah.
Goodbye.
Good night.
Thank you.
Thank you, bye.